Imagine for a second that every time you filled up a bucket with water, more than half of it just leaked out before you could even use it. It sounds crazy, right? But that's pretty much exactly what's happening with our global energy supply. We generate a massive amount of power, but a huge chunk of it just vanishes. Today, we're going to go on a hunt and find out where it all goes. It all starts with something really small, something I bet you felt 100 times. That little bit of warmth coming from your phone charger, yeah, that's not just some weird side effect. That is literally wasted energy escaping as heat. It's a tiny, tiny symptom of a much, much bigger problem. So the best way to think about our entire energy system, I'm talking from the power plant all the way to the light bulb in your room, is as one giant leaky bucket. We're pouring enormous amounts of energy in at the top, but all along the way, it's just constantly dripping out through countless invisible holes. And this brings us to a really key idea: energy efficiency. It's actually a simple concept. It's just the percentage of that water that actually makes it where it's going versus how much spills out. So our goal? It's simple. Plug the leaks and keep that bucket as full as we possibly can. Okay, so where are all these leaks? Let's go find them. It turns out there are four main culprits, four invisible thieves that are constantly siphoning energy right out of our system. Let's unmask them one by one. First up is electrical loss. Think of it like friction, but for electricity. As power travels through thousands of miles of wires to get to your house, the wire itself actually resists the flow, and that generates heat. Well, that heat is wasted energy. The very same thing happens inside every single transformer you see hanging on a power pole. Next, we've got mechanical loss. Now, this one's probably more familiar to you. Good old friction. Every single time parts rub together, in a car engine, a factory machine, or even just a simple fan, energy is lost as heat. And air resistance, or what engineers call windage, does the exact same thing, just robbing energy from anything that moves. Our third thief is thermal loss. This is that heat you feel coming off your laptop or your TV or, yeah, that phone charger we talked about at the beginning. It's also the heat that escapes right through a poorly insulated roof in the winter. All of that warmth is just energy that isn't doing the job it was supposed to do. And finally, we have the sneakiest thief of them all: magnetic loss. This happens deep, deep inside electric motors. As magnetic fields flip back and forth thousands of times a second to create motion, they create this kind of magnetic friction, these tiny little internal currents that do nothing but generate heat. It's a silent but a really significant drain on our power. So, after we account for all those leaks, where does the energy that does make it through actually end up? Well, it turns out our power consumption is really dominated by three main areas. The breakdown is pretty fascinating when you see it laid out like this. Our energy use splits into three huge categories. We've got the industrial sector, with all its factories and manufacturing, then the commercial sector, which covers everything from offices to malls to hospitals, and finally the domestic sector, which of course is all of us in our homes. At home, the culprits are all pretty familiar. We're talking about the constant hum of the refrigerator, the fans and air conditioners that are always battling the heat, and every single light we leave on. Each one of those adds up, and it makes for a pretty significant slice of that domestic energy pie. Now, in the industrial world, the scale is just massive. We're talking about huge electric motors that drive things like conveyor belts and heavy machinery, and enormous heating equipment for processing materials. These things are the absolute powerhouses of our economy, and they are incredibly energy hungry. And in our commercial spaces, think office buildings, it's the systems that keep these huge buildings comfortable and running that use the most power. HVAC, that's heating, ventilation, and air conditioning, is a gigantic consumer, along with all the lighting systems and the constant motion of elevators. So knowing where the leaks are and who the biggest users are is one thing, but what can we actually do about it? Well, the good news is there are some really straightforward and effective ways to start plugging that leaky bucket. So how do we fight back? There are four really powerful strategies. We can start by choosing smart tech, energy-efficient appliances that stop the waste right at the source. We can keep our machines properly maintained, because a well-oiled engine is an efficient engine. We can insulate our buildings better, trapping heat where we actually want it. And finally, we can embrace renewables, making the energy we generate cleaner from the very beginning. Ultimately, when you understand this leaky grid, it brings the whole problem right back to our doorstep. It's not just about some distant power plant, it's about the choices we're all making every single day. Every watt we save, every tiny leak we plug, sends a ripple of efficiency all the way back through the entire system. I think this quote just sums it up perfectly. Before we even start talking about building new power plants or finding new fuel sources, the most powerful thing we can do is to simply stop wasting the energy we already have. Conservation, that is our single greatest resource. So I'll leave you with this question to think about, whether it's unplugging that charger, or sealing a drafty window, or choosing an LED bulb over an old one. What's one leak, big or small, that you can go out and plug this week?